Welcome for this first episode of the Risk Radio here in the offices of RiskConcile in Leuven. And today we're going to talk more in particular on the implications of AI in the asset management industry. I am in good company. I'm here together with Sofie Reyners and Linders. Sofie used to be a former PhD student of mine here at the University of Leuven, and now you're a quantitative analyst at KBC Asset Management. Maybe you can explain a bit more about what you do, what your job is about.
Yes. So I'm working as a quant at asset management, and that means that we create models and data-driven insights that are used by the portfolio managers in our company.
Thank you. On the other side, I'm having Professor Linders, Linders. I'll say Daniel on this podcast. You're more the theoretical angle from this podcast. You're attached to University of Amsterdam and KU Leuven. Maybe you can shed a bit more about what you do in your research, more on the aspects of AI in the asset management industry.
Thank you for inviting me to this podcast. My research is around risk and risk management. So I teach courses at KU Leuven on quantitative risk management. And in Amsterdam, we teach courses on data science to bachelor students. We teach advanced machine learning to master students.
Fantastic. So you see we're in good company. We have the theoretical and the practical side all together here on this particular podcast. Thank you. The first section will be about the current use of AI in the asset management industry. So AI is everywhere. People talk about it everywhere. So Daniel, maybe first question to you. What do you see currently from happening in the academic world when it comes to AI in the asset management industry?
So I think that the current research papers are more and more focusing on solving issues that we know that are around in asset management and risk management, but can now either tackled with AI and machine learning, or sometimes the AI and machine learning algorithms can provide new or alternative solutions to problems where we have more classical solutions. So then it's a matter of a comparison, maybe cost-benefit comparison between what we have and what new solutions with AI are. And maybe as an example, we have the classical Markowitz setting for portfolio selection. Then we know that it's very complex to estimate covariance matrix to find asset returns, average returns over time. Maybe there is a role for machine learning using advanced methods to get these estimations better, to then put them in the more classical frameworks of Markowitz portfolio selection and its derivatives.
The word Markowitz has been a buzzword dropped on this table, so I now move directly to practical aspects. How does it all work at KBC Asset Management?
Well, actually, I recognize a lot from what Daniel has been saying there, because indeed we do apply AI techniques for the estimation of expected returns that are then imputed into the Markowitz framework, for instance. That is one of the things we spend quite a lot of time at.
Okay, and how can you as an asset manager, Daniel, distinguish between what I say as a true AI solution and some automated, let's say, kitchen rules, some basic things that are very often confused? How can you make a distinction between those two?
Yes, I think that's a good question, in the sense that if we talk about true AI solutions, we mean solutions that can adapt to new incoming information, to new data. And I think that if we start from a more rule-based solution, then as an asset manager, for example, we can better control the solution, because basically what we do is we determine our decisions with if-else statements to say, well, if this happens, then we should do this. It gives control to the humans who are supervising the system, but at the same time, with the true-based AI solutions, we can let the system decide where we want to go. And I think that in some cases can result in new, maybe unexpected solutions that as a human you wouldn't step into a certain trade or a certain decision, but the system tells you maybe this is a good idea. And I think there's this comparison, if I remember well, with the chess games that they try to do with the Deep Blue, and then you had the AlphaGo. They also see this difference between true AI, where the AlphaGo was able to like learn the game by playing many games and to make decisions. And with the chess game, I think they just put a lot of information in the computer and then try to say, well, if this happens, you have to do this. If this happens, you have to do this. And I think then in the framework of the solutions, the rule-based AI is much more linked to a particular problem, because we are going to say, well, this is the problem we want to solve. And then these are the steps you have to take. If you change the problem, we have to feed different information. I think the two machine learning methods, they are much more general, and depending on the data, the machine will decide what direction to go.
So, Sofie, we are both in the same bucket here. We actually are practitioners. So our future colleagues are going to be probably trained by Daniel here at this magnificent Leuven, city of Leuven, the home actually of KU Leuven University. Our future colleagues, how are they trained by you? I mean, what do you have? What is at stake for getting the future students up to skill, up to speed with these new technologies? How do you handle this?
I think students are more and more aware that knowing machine learning AI is very important. So there is a high demand from students for machine learning AI courses. And I think our task is to make courses where they can learn the machinery of these machine learning methods. Because I think that by the time they come, for example, to KBC, it is not sufficient that they can just apply certain machine learning methods. They have to understand what are the specific problems of the company, and how can I use machine learning methods that I maybe used at university. How can I use them? How can I tailor them to solve this type of problems? I think that's the first goal of the education that we give, to really give them the technical skills to develop models, and also we train future asset managers for next year and in 2 years, but also they will stay in the company hopefully for many years. In 10 years, they should still have these. They should still be able to use these skills that they learned at university to adapt to evolutions in 10 years. So I think to give this broad basis of machine learning AI that automatically includes a lot of mathematics, I think that is one of the important tasks of the universities. I think the second part of the education that I think at the moment is maybe a bit lagging is to focus on like new issues that arise because of this AI, that has to do with privacy, with big data, with responsibility in using solutions. I think at the moment that is not a big issue, but with the increasing demand and use of AI, I think these are also issues that we have to highlight in our education.
Yeah. Well, our future colleagues are in good hands. Now, while we're talking here, Sofie and Daniel, somewhere maybe in Leuven, some students think about a bright idea. Maybe they're gonna build a startup, new solution. They probably will try to sell this to KBC Bank, whatever. So how does a bank look at off-the-shelf solutions? Do you buy those, or are you saying, well, we prefer to develop at KBC Bank our own models, our own technology? Where is the balance here, the trade-off here at KBC Bank?
Well, finding that balance is an important part of our jobs, because of course we are building things ourselves. We are quants with a mathematical profile, a computer science background, but we can't build everything ourselves. We are no Microsoft, we know that. So we are always finding the balance between building things and buying solutions off the shelf. And then our task is to integrate both parts, so that on the one hand we can buy top-notch technology off the shelf and integrate it into our systems by building something around it to really make that solution tailor-made to our clients.
Well understood. So this actually closes the first question. Where is AI for the moment? the academic side, training the students, buying the products, and that allows me to move to the next question. This second section, we're going to discuss the risks of AI and what it brings to us, together again with Daniel and Sofie. And so how do users generally perceive those risks of AI, Daniel? And what is the risk of automation, checks and balances and so on? These are questions I would like to ask to you first.
I think there are two issues that we can focus on. The first is that research has shown that there is also something among the users of algorithm aversion that is similar to what we know in behavioral finance as risk aversion. It does not mean that we are necessarily against AI or machine learning methods, but if we assess the risks, then there is some asymmetry on how we perceive the good and the bad parts. We put more emphasis on the negative outcomes. We are more afraid that the machine learning algorithm maybe will result in lots of losses, rather than we are very optimistic, very happy for possible future gains. So there is aversion against these machine learning algorithms, but the degree of this aversion also differs among different persons, similar as the risk aversion. So you can imagine that users who have a lot of knowledge about AI, who maybe are also dealing with these machine learning algorithms, they are much more optimistic about the use of AI for their investments than people that are a bit further away. So I think that in designing these solutions, you also want to take into account this aversion. Like the same solution can be optimal for one person, but not for someone else. Again, there is this link or this similarity with risk aversion. I think the second issue on the oversight that you mentioned is that, of course, with the use of AI, we know that things can go wrong. And I think maybe we have to say that we know already by now that at some point something will go wrong with the machine learning method. It's a new kind of operational risk that you have. And I think there is this example of a balance sheet or a statement of the company Lyft, where they put like 0 extra or too little, and that resulted in like the wrong interpretation of the AI models. So I think there needs to be an assessment of the new risk that is induced by the use of AI models.
So, Sofie, you work in the regulated industry. So KBC, the regulator, is the European Banking Authority. Asset managers, the ESMA, the regulator of the asset manager companies. Insurance have their own regulator. How do the regulators look at this in terms of proportionality, for example? How does that work?
From my side, I can say something about the insurance part, because I am currently in the actuarial science and math finance group in the University of Amsterdam, so we do a lot on insurance regulation. But of course, on top of that, there is a European regulation, the AI Act, that already says what we have to do with AI, or at least give some guidelines. And in insurance, it's important that there is this proportionality. So it means that if you use AI, then the regulation that you have to follow depends on how you use it and what are the possible consequences. If you use AI to determine certain risk assessments or premiums for life insurance or pension products, then this can have, then if something goes wrong, then this can have like extreme negative consequences for a large group of policyholders, but also for the society as a whole. So there the regulation is much more strict than when you use it in some other cases where it, for example, goes on a one year basis, like car insurance. There the possible damage to the bigger society is much more limited. So the regulation stipulates a bit what is considered as high risk AI and what is like lower risk AI. And at the moment, there is some consultation paper of the EIOPA is the supervisor for the insurance companies. So they try to come up with guidelines how to deal with this AI Act that then at a later stage will be implemented in national regulation. But that, at the moment, as far as I know, is still an ongoing project.
Recovery risk means there's risk for mistakes. I recall that there's a website out there where you can follow the mistakes being made by Excel. Excel, horrible, you have made a lot of mistakes. Same for AI. I think if you type mistakes made by AI, you're gonna bump up some websites. Puts it in perspective. So, Sofie, my question to you, actually, humans are still necessary. And at KBC Ashman, how do you look at that AI and the human angle? Can we get rid of the human? Is human aspect actually 100% necessary for the moment at the work floor, at the asset management floor?
Well, to comfort you, I think humans are still very necessary in that process. Yes. To come back to that AI Act, when you look at that European AI Act, human oversight is something that is mentioned there a lot as well. And we also value that a lot. So in our opinion, human oversight of AI models is very important. I don't say that a human overlay is always necessary. It really depends on the model, on the application, on where do you apply the AI. But once you have an AI model, you can look at the outcomes of it. And then I think there should always be a human who is evaluating what the AI model does. So I don't say the human has to change the outcomes, but has to validate, does it make sense? Can we go along with this? That's a very important aspect, especially in our business, in the asset management business, where we are working with real people's money.
Well, thank you. So there are risks. There's the human input, the human overlay. And so next question, I'm going to ask a little more about the future. So we talked about current use, the risks, and then I would like to address now something else, which is about the future possible use of AI on the floor in academia. My next question will be about the future use of AI. I always have the impression that, look at you, Daniel, that my students, sometimes they skip. They forget about statistics and about all probability theory. They go straight into using some kind of an AI model. How do you look at that, about skipping those steps, basically?
Yeah, we see that in the university, that indeed students very quickly want to go to the advanced machine learning AI models. They know the buzzwords, so to say, so they want to implement a neural network. And I think it's still important to teach the basics, statistical learning from the classical textbooks. Because what we learn our students is that the problems we want to solve with AI are the same problems in, say, mathematical terms than the problems you want to solve with statistical learning. If you go back to a linear regression model, it's a conditional expectation at the end that you try to find, and we can then build more advanced models. But I think to compare these models, to see what is it worth the cost to invest in a very advanced machine learning method, we have to understand what is the basic model and how can we test if a model outperforms another model. And I think that goes back to the basic statistical learning.
Thank you for the insight, Daniel. Now, Sofie, 4 years ago, you're doing a PhD research here at the university. So if I recall, at that time, you were applying machine learning on derivatives pricing. If I recall, even further than I think was the application of Gaussian process regression, derivatives pricing, a long time ago. Now, if I would allow you to look 5 years ahead, 10 years ahead, where do you see all of this AI happening, taking place, changing the asset management industry, the day-to-day job?
Well, a lot of things have changed between 4 years ago and today. And I think the most important thing that happened between 4 years ago and today was the rise of generative AI. So 4 years ago, everything was about predictive modeling, machine learning, and the Gaussian process regression that you said was one example. But now with Gen AI, a complete new way to apply AI models has appeared. And the biggest difference is that the way in which you can apply Gen AI goes much broader than purely what we were doing with machine learning. Machine learning, we predict alphas, we predict expected returns, or we predict signals that we apply into really the core of investment management, so portfolio building. But with Gen AI, you can change the asset management industry from a broader perspective. So, for instance, you can apply Gen AI to help you with client after-sales reporting, for instance. It's a perfect tool to create communication to your clients on a very personalized level. That's one example. But Gen AI can also be applied on the other sides of the asset management company. For instance, by us as quant researchers. We typically read a lot of research papers. We are spammed by broker research. There is so much information out there. And the capability to summarize texts, that's one of the most famous examples of where Gen AI is known for. So if we use such a Gen AI tool to summarize broker research for us, or to point us at, hey, this paper might be useful for you, specifically to the research you are working for, well, then that can save us a lot of time, and that can make us way more efficient in what we are doing.
If I listen to all of this, Sofie and Daniel, then I wonder myself, will there still be room for traditional research? Will people be able to read the balance sheet, for example, or work with multiples, or do the more cash flow discounting to build some kind of valuation model? Will this still be the case?
I think it is still important to teach this traditional research topics. If I refer to your paper on the machine learning and the derivative pricing, then I think the core problem is the derivative pricing or the calibration of your model to the option data. And it is a bit similar to the example I gave with statistical learning versus the AI models, that we try to solve a problem with complex machine learning or AI tools, but then we still have to decide, are we satisfied with that solution? And to know if you think that this solution is a good one or that we can improve it, you have to understand what is my core problem. When am I happy enough with the solution? And I think then you have to go back to the basics, to the core problem, and say, well, this was my problem. I want to use it for this purpose. So it means that I can live with, for example, a calibration error of this magnitude. So I think in that sense, it is a tool. The machine learning is a tool, but we have to understand where we are applying the tool to understand, okay, this is a good use, or we can better use alternative methods.
So it's a tool, so you said, Sofie, it's a tool. So using it for post-sales analysis, for broker research. Our tools 20 years ago were our MATLAB code, our personal computer. How does the AI-equipped fund manager looks like for KBC Asset Management?
Well, in a future world where AI will be integrated everywhere, AI will also be integrated in how we perform our work. So I think that AI models will support us as a co-pilot and help us in what we're doing. I don't believe personally in one team that is really focusing on the AI and the others are fundamentalists. That's not how an optimal organization works. But I do believe that in every team or every part of an asset manager, it makes sense to have some knowledge about AI and to really have AI integrated into the different things that we are doing as a help, but still being supported by, or not supported by, but still being led by a human who is accountable for the results that we are producing.
Okay, thank you. So that's about the tools. The tools need fuel. The fuel is data, expensive data. You cannot go around it. And that's going to be my next question. Will be really focusing on the data. as the foundation of AI and how you guys look at it. In this final question I would love to ask is about data. So here also the RiskConcile data is our biggest investment. It's the most expensive investment. It doesn't really stop. I expect for you, Sofie, as a practitioner, KBC management, you guys are consuming lots and lots of data. That must be very costly exercise as well.
Yes, of course. At KBC, we continuously monitor our costs, and the same holds for data, which indeed is increasingly more expensive, especially when you're using more and more data into your models. So, for instance, I can give a little example. In fact,
so, yeah?
Last year, at the end of last year, we suddenly got a message from one of our data providers saying, hey, as of next year, we will charge you $85,000 for this specific package of data. Data that we were relying on, that we were using in our models. But of course, that's a huge cost that adds up to the already existing costs. So in that case, we evaluated, does it make sense for us to keep this data into our models? And the conclusion was no, it's too expensive for what it is. So we decided to not go for that contract. But it also means that you have to adjust your models, you have to retrain your models, you have to retest your models. And by then, you can finally put your new models into your production environment. So the monitoring of costs, it's something that is costly as well, in fact, because you have to spend quite some time at that. But of course, it's better than simply just paying for everything that exists, as more and more is becoming available there.
Okay, and so the data gets stored and governed. And how do you look at the quality of the data? How do you monitor that?
That's also very important. So how we do it is we store the data that we use in our models in a cloud environment. And before the data gets ingested in the models, there is a quality framework around it. So every data point that enters the database is being checked. So there's a list of rules that applies for every kind of data. And when it doesn't follow the rules, then a flag goes off and a human will look at that data point. Does it make sense? Do we have to correct it? Or is it normal that this data point has a high value today? Maybe because, well, in this economic reality, sometimes we do have weird data points. So that human oversight is also applied.
So
data quality.
Data can have outliers, but it also can be some propriety, some sensitive aspects in data. Daniel, how should we handle this, and how can we deal with this sensitive area of data?
I think for academic research, the use of data always has been very important, but nowadays is becoming more and more important. And because of these privacy issues, it becomes more and more difficult to get this type of data. For example, you can have issues with privacy of, for example, policyholders that are in your data. So somehow you want that this anonymous, but also there is a privacy of a certain company that you work with and where you use the data. Of course, they maybe don't want you to publish certain results that are linked to their data. So it makes it more difficult for academic researchers to find the right data to conduct the research. At the same time, there is a stream of research that tries to overcome that issue by starting from real data sets, but then from there on trying to create synthetic data sets. So data sets that are not real in the sense that they are not linked to real data, but they are created in such a way that they keep the structure of the original data set. Of course, this is a very difficult and sensitive exercise because, of course, in this conversion from real data to synthetic data, if you make a mistake, that will also appear in your model and in your outcomes. And I think that is the main risk of using this big data. As Sofie mentioned, we have all this data, but we are still checking the data, and sometimes there are red flags. Of course, you are changing the data and you have to check like how does this change of the data where we maybe removed or we added some values, how will this change propagate in your model and at some later point maybe in your results.
You mentioned the word big data. So then you guys must be using KBC, you must be using trillions and terabytes of data. Is that volume an issue?
Oh, I would say big data, it's not purely about volumes of data. In the last years, we have seen so many different kinds of structures of data that have become available. And it's about finding a way between all those different types of data. What is useful for us? What can we do with it? And then in the end, how do we translate that data into a signal that is useful for us? For instance, the easiest example, textual data. So there are news articles out there. There is a lot of text being written every day. And there's a lot of useful information in that. But if you just store all of that, you don't have a signal yet. So the task of converting that data into the signal, that is one of the challenges that we are having at the moment.
That's a challenge. So the data is the fuel of your engine. The engine needs to be maintained, needs to be kept in good shape. Can I summarize it like that, Sofie?
That's a perfect summary.
I'd love to hear that. So I think Daniel, want to comment on that aspect of the engine and the fuel?
Well, I think to comment on what Sofie just said about the large amounts of data that some of you have to handle to see what is useful, there is first of all the question, like you say, you have to see, okay, can we use or is it useful to use these and these variables? But there are also these technical issues where we know that if you have lots of data, there is overlap in your information that is contained in your variables, so collinearity issues automatically arise there. So I think that if we have all this data, you need to handle it in a smart way to avoid technical issues that can lead later on to mistakes in your model.
Well, thank you for this insight. So this closes down actually our podcast today. It's very great to have two angles here, the academic world and the practitioner world. I go a lot to seminars, then I meet the academics. I go to big events, then I meet the banks. Now it's having you both here on the table. So thank you for being here. And for all the listeners, stay tuned and listen to our next podcast coming soon. Thank you very much. Thank you, Sofie. Thank you, Daniel.
Thank you.